Hello, welcome to Sunday Science Q&A. This is a quantum theory special, so this is going to be very, very exciting because this is always it is always a joy to see early attempts at brevity before that is thrown out of the window when dealing with quantum theory. And I will tell you a few quick. In fact, I'm going to recommend this book as well, Stranger Than We Can Imagine, which is a fantastic book by my friend John Higgs, and I've mentioned it many times before. And we've had him on Book Shambles, and one of the reasons I love this book is it's basically about the loss of centre for human beings, that when we finally enter in the 20th century into a kind of probabilistic universe, we've lost the final omphalos, the final kind of central thing that we can grip onto, and how that affected art and politics and culture. But he has this beautiful description of wave particle duality where he says it's basically like describing something as both a brick and a song, and I think that's such a lovely way of him starting in that book. So I just wanted to recommend it again. I recommend it a great deal because it's one of probably my favourite books, and we are joined by people who have written some of my favourite books as well today. A couple of other things quickly, which is if you support us via Patreon, thank you very much. That helps us make all of the shows that we're still making during whatever kind of semblance of lockdown or not lockdown or whatever it is that is going on. And so we're still trying to make as much as possible. If you are able to support us via Patreon, that's brilliant. If you're not able to, but you have a little bit of spare cash, we have a tip jar somewhere on the screen, and you can leave a financial tip. We don't need your philosophical tips. You can, well, I mean, actually, we can have those as well. If you'd like to leave those, that's fine. And if you have no money whatsoever, or really you don't want to pay for it, that's absolutely fine as well. We want to make sure that as much as what we do is free to access. So that's a few things. I also want to mention one other thing. I've got the Blue Dot and Cosmic Shambles interview that we did with Andrean, Brian Cox and myself, that is now up on YouTube. That went live on the Blue Dot Festival yesterday at midday, and we had a lovely conversation about the Golden Record and about the work with Carl Sagan, about when they made Cosmos together, and Shadows of Forgotten Ancestors, and many other things as well. So you can see that. What else have I been given in my notes? Oh, next week's Q&A is the brain. That's great news, because if any of you have heard the recent Infinite Monkey Cage on the brain, where we didn't even get to question one every time. It's fine if we do it sometimes with other creatures' brains, but the moment you get to the human brain, we got nowhere. But I'll tell you what, it was a very interesting journey. It was a bit like Mad Max Fury Road, I suppose, really. We ended up where we started, but nevertheless we saw some interesting things on the way. And also there's a new video out on the Stand Up Maths channel, Matt Parker Stand Up Maths channel, collaboration with Matt Parker, Hugh Hunt, and also Helen, about ellipsoids. And so yes, and if you can also subscribe to our channel, that is fantastic as well. I think I've mentioned pretty much everything, so that's fun. And I will mention finally one thing which I really recommend highly, and a lot of people I've spoken to didn't know about its existence, but there's it's not a happy documentary. It is a documentary that may well make you frustrated and angry, and at times possibly very sad as well. But I really recommend, if you get a chance, to watch the BBC Three documentary False Hope, about alternative cancer cures, which looks in particular at a young guy called Sean Walsh, who was a young musician in Merseyside. And it's a very, very, and also you can then go and listen to Skeptics with a K, Michael Marshall and the other Merseyside skeptics, I think, do a really great job, because their skepticism is so much rooted in humanity and their worry about humanity and their hopes. And, you know, it's not, to me, it's never been, as sometimes people seem to think, you know, it can be cynical, or it can be smug, or it can be kind of superior. Their work, and the episode they've just done about the false hopes in alternative cancer cures is very, very good. So that is that's probably one of the longest annotations that I've given to the introduction. So let's now meet everyone that we've got. We will start off with every Sunday she is here, which beats me, because one Sunday I didn't manage to make it. It is Helen Chersky. Hello, Helen. How are you?
I'm very well. How are you?
I'm good. Now I'm going to get straight in there. Your show and tell. So
I got a new bookcase, and that meant I could get books that have been in boxes, out of boxes, and put them in the bookcase. And that means I found some new books that I've been carrying around for years. And this book, I remember my parents having when I was a kid, and I obviously picked it up. It was published in 1970, by this person, I.O. Evans. I looked to see what else they had written, and they had written The Guide to Collecting Cigarette Cards. But apparently they're journalists. But what's interesting about it is that it goes through, from the 1970 perspective, it goes through all the theories of the way the Earth is and the sort of development of ideas. And what's nice about it is that it's 50 years old. It's got some crackers in it. So my favourite is somewhere down here. I've no idea whether this is true. If anyone is a medievalist and knows this or knows about the Middle Ages. So there's on this page, I think I might just have broken the book. On this page here, there is, down the bottom there, you won't be able to see it, but it says, it talks about where people wondering where stones had come from in the Middle Ages. And it says, a few stones are hollow with small pebbles inside them. How natural to assume that the inner stone is literally the offspring of the outer one, and that the latter had, so as to speak, given birth. How natural to deduce that some stones have a sex, being either male or female, and that stones can literally grow within the earth. And then he points out that things like kidney stones do operate like this. So there's some lovely ideas in there. And then the thing I like most of all is that literally just before they published it, a couple of months before this must have gone to press, the Apollo missions got to the moon. And so I just quite like this as a reminder that in 50 years we did know quite a lot. Plate tectonics is in here, evolution is in here, although he accepts that no one really knows how it works. Why it works, but it's just like the development of ideas. It's just a bog standard book from 50 years ago, and it's quite nice to see what they thought. So that's my.
There were loads of those. That was a good series, as far as I remember. They and it's always fantastic illustrations, very beautifully. And then you had the tragedy there, which is of course publisher's idea, perfect binding, as it was called, which was far from perfect, and which is why very often you find an old book and you go, I love this book, but if I open it, will all the pages fall out as the glue stops holding them together?
That is exactly what has happened to this book today.
That is, that's always the danger. That's it. Will you keep it as a Schrodinger's book filled with possibility, or do you dare open it and therefore kill the book? Someone who's, it's always a danger to say his most recent book, because not only is one of our guests tremendously prolific, and I really his work is always enlightening and always fascinating and always approachable for people like me who are not scientists, and beyond weird. Was that your most recent book, or have I missed it?
It wasn't my most recent book.
I knew it.
I'm looking for it now for the most recent. As a bit of free advertising, and I don't have it. My most recent book was How to Grow a Human, and it was it was really launched from this experiment that I took part in several years ago, where scientists at UCL, neuroscientists, grew me a mini brain. And they grew it from a piece of my arm. They took a little bit of skin from my shoulder and cultured it into stem cells. And from the stem cells, they grew them into neurons, and the neurons grew into a little tiny brain. It was about this big, about the size of a lentil.
That's quite big.
And it's great. I mean, you can see it exactly.
On the scale of these things.
Yeah. It's not bad. It's kind of, bird-sized or something. And I have wonderful. They had lovely microscope images of the stained neurons joining together, and it was extraordinary. And the book is all about. So this is nothing to do with quantum mechanics, but the book is all about that technology for reprogramming cells, including our own cells, so that we can reprogram them to become like the cells from which our embryos grew, and then you can grow them into any tissue, including a mini brain. So that's the latest book.
See, that worries me slightly, because it reminds me of the Bruce Robinson, Richard E. Grant movie, How to Get Ahead in Advertising, in which someone does start to grow a head pretty much out of their neck and across their shoulder as well. So I now no longer know if we're seeing the original Philip Ball, or whether that was actually consumed by an avaricious brain that was created by you. You've got a show and tell as well.
I have, yeah. I grabbed one off my shelves and it was, but I just happened to have this thing sitting nearby, and I hadn't thought about it for ages. This is, you might just be able to see, it's a force multiplier, the principle of Sato's force multiplier. When I worked as an editor at Nature, we would get the most fantastic papers sent to us by people who weren't professional scientists and had just hit on an idea that explained the universe, or usually explained the universe, actually. In fact, we were talking just before we started about how this happens with quantum mechanics in particular, and I regularly now get sent people's alternative theories of quantum mechanics. But I got very familiar with with this whole world of, alternative physics through being an editor at Nature and having to deal with these papers. Mostly they were just papers, but just occasionally you'd get something fantastic like this come in the mail. And so this was sent to me, and I don't know what it does exactly. It has moving parts, and I'm not quite sure what they're meant to illustrate, but it was clearly illustrating this guy's theory of probably an alternative Newtonian theory for how force works. So I've kept it all these years because it's actually rather a lovely thing. It's rather beautifully made, and I have never really known how to work it.
You realise what's going to happen now is that you're going to get loads of letters from people who have watched this going, oh, I know what the theory is, and then sending you 50-page documents with their theories on there.
It's already happening, Helen. Writing a book about quantum mechanics is an open invitation to do that. And I've tweeted to say, look, by all means send me your theories, but I will not comment on any of them. And in fact, the truth is, if you need me to comment and pronounce on whether your theory is any good, then probably you're not on the right track. So I'm already there. But Jim Al-Khalili is more. If you have a theory, send it to Jim.
Don't be mean.
Yeah, no. It'd be nice. Jim likes it.
You know what, though? If you do have a theory, don't the nice proper letters, because the fun ones are the ones where people actually bothered to write a nice letter and didn't just copy and paste the same email. So if you're going to have theories, I think present them nicely.
Well, very interesting. That's true, because generally speaking, I can recognize these emails because there's no kind of formalities or niceties. They just launch straight into their theory of quarks, which is kind of, a curious approach. So, yeah, you're right, Helen. It's, a nice little intro helps.
Well, you've all invited this, be it on your own heads. And now we are one of the... I've not been to that many physics lectures, but I went to her, as far as I remember, it's third year. I hope I'm right. The introductory third year lecture on general relativity, and it was really fascinating. It was. I think I was working on a show at the time for Radio 4 about relativity, and she was recently also on the Infinite Monkey Cage talking about time with Carla Rovelli and Mark Gatiss, and is a big Alan Moore fan as well, which later on we may well all link together in Jerusalem style. And that is Fay Dowker. Hello, Fay.
Hi, Robin. Hi, everyone.
Now you have time, wasn't it? Because we ended up feeling as if we had very little time to deal with the nature of time. I felt I'm not sure. It's often interesting, that bit where perhaps, I don't know if you feel like this, because it's something that everyone thinks they know what it is until they're questioned. It means that from the very beginning of the show, because you open that up, it becomes increasingly complex. Would you say that's fair?
Yeah, you have to define what the question is. What exactly are you is on talking about? When I found, it was a difficult show. I agree. I'm not sure we got really to setting out exactly what it is that we wanted to debate or the different points of view we wanted to explore. So it was kind of tricky. I mean, the idea of setting out maybe alternative perspectives is a useful one. So the one I like most for time is this dichotomy between being and becoming. So being being the block universe, all the events in the universe, past, present, and future, are equally real. They're just laid out once and for all, versus the idea that time is a process, that there is becoming, that the world comes into being in a process, and that process is the passage of time. So those, to pit those against each other, can be a useful way to frame a discussion, I thought. So anyway, but we'll see what people think, I suppose.
Well, a very simple introduction, if anyone wants a simple introduction into the block universe, is merely to read Alan Moore's book Jerusalem. That won't take much time, I promise you. It is merely as long as the Old Testament, and it was his kind of, when I don't know where he first read it, when he was reading an article about the block universe, that played a major part in him then writing this incredible book about Northampton and about history and about physics and so many different things. Do you have a show and tell for us, Faye?
I do. It's also a book. So here it is.
Oh, right in front of your face. Oh, you go totally invisible. Oh, this is great. This is like watching the 1970s David McCallum film, The Invisible Man.
Okay, I'll just have to describe it to you. So
no, we can see it now. We can just see it. Keep it there. Yeah, the nature of space and
Ooh, The Nature of
The
Space.
universe is playing tricks on us.
Yeah, by Stephen Hawking and Roger Penrose. So it's the record of an amazing event, intellectual event, that happened in Cambridge in 1994. So it was a series of lectures, alternating lectures by Stephen and by Roger, setting out their views on both their contributions to fundamental physics and relativity and quantum gravity, and their views about the directions, the most interesting and fruitful directions that should be pursued. And there was a debate at the end between them, toing and froing. And it was, I have to say, totally thrilling. I mean, I was a young scientist then at the beginning of my career, and I just felt this is what I want to be involved in, this kind of thing. I want to think about these sorts of things. I want to contribute to this kind of activity and this quest to understand the world at its most fundamental level. And so, it brings back great memories for me. But I want to quote to you from the beginning of the debate. So this is chapter 7, and it's Stephen. So he says, these lectures have shown very clearly the difference between Roger and me. He's a Platonist, and I'm a positivist. He's worried that Schrödinger's cat is in a quantum state where it is half alive and half dead. He feels that can't correspond to reality, but that doesn't bother me. I don't demand that a theory correspond to reality because I don't know what it is. Reality is not a quality you can test with litmus paper. All I'm concerned with is that the theory should predict the results of measurements. Quantum theory does this very successfully. So, and at the time, I remember, so I've gone through a process of development and deepening of my own thoughts and understanding on quantum theory, but at that time, I sided very much with Roger and against Stephen in their debate on quantum mechanics. And I felt that very strongly I would never say I was a Platonist, but certainly with Roger that physics should describe reality. And I think, and I wasn't satisfied with Stephen's view. But now I feel I know what Stephen means now. I think I have a deeper understanding of what he means. He was being deliberately provocative, which was definitely a style of his. But I'm now halfway in between them. So, that's.
This is now we don't know which way you're going to go now. So there's a tremendous bit of do you return to where you came? Do you go? The Platonist thing is interesting. I was talking with Natalie Haynes the other day, and she said that the classicist Edith Hall said that the reason that Plato was disappointed by the world as it was and hoped that there were perfect examples of those was because he was very, very short-sighted, and so he saw the world entirely blurred, whereas Aristotle had very good sight, so he was seeing things and he went, this is, and I think that's a very interesting and Natalie says that Edith Hall gives a very good argument on that. And so if he'd just become a painter like Turner, it would have been fine. So many questions. We're not going to get through them all. So let's start off with Ed Morris's son has a question. He would just like to know, where does the universe stop? Now, I think this is a very interesting thing. It's very hard to imagine that something is ultimately not held within something else, that there's not some wall that you can then go further into another world. So who would like to, Helen, shall I start with you? It's a tricky one, that idea of
whether you mean in space or in time, and they're sort of linked ultimately, but we think of things stopping either as you carry on in time and then it stops tomorrow, or that you get to the edge and then it stops like a coastline, I guess. There's obviously a lot of debate about this, and actually it's really interesting because I think it comes back to what Fay was saying, which is that you can have theories that work very well for prediction, but they may not mean anything, but they work, or you can have a mechanistic understanding of this is what's actually happening. And my understanding of this one is that the universe in time, it seems it will keep going. Seems to have decided it's expanding and it's going to keep expanding. And we don't know what that means. And in that case, perhaps when it stops is when everything's just run down. Entropy has reached its maximum extent. And sure, the universe is there, but all functional things within it have come to a stop, which is kind of an unsatisfying answer because it's a bit of a zombie state for a universe to be in. But perhaps that's what's waiting for us. And it's maybe cleaner for the human mind to go, there's a stop. Like the restaurants at the end of the universe, in The Hitchhiker's Guide to the Galaxy, where they know and there's a big crunch and then it all stops and everyone knows when the stop is. So it might, I'm not an expert on the latest, where these theories have gone, but it seems to me that the problem with this answer is that people have probably said it a lot, but because it's not a satisfying answer to a human, people find it hard to take in, so they keep asking the question. But the other two have probably got far more sophisticated ideas about this.
Well, I wonder, because
there are places in the universe. There are places in the universe where time does stop, and that's at the singularity inside a black hole. So at least our physics stops there. So our understanding of the physics stops at the singularity of inside a black hole, and at that time, it's as if a mini crunch takes place. So the big crunch is the sort of the time reverse of the Big Bang. So it's where everything becomes very compressed and very very hot and very dense. So that happens inside the black hole, and there's a localized collapse to a singularity inside a black hole, and our physics stops there, and we don't know what happens if anything happens after that. But interestingly, in some of the work that I do, it suggests that even at the singularity of a black hole or a big crunch of the whole universe, that the universe will continue afterwards. There will be events that occur after that crunch. So, and that time will never end in that sense. The universe will carry on. But we don't know. That's speculative science. That's the realm of quantum gravity.
Phil, I'm going to move on because we've got so many questions. This is from Penny, and Penny would like to know, do you really believe in parallel universes where there are infinite versions of yourself?
Believe in that, but it's not I mean, at the moment, all we can say, it is just a question of belief. There are people who support, this is the many worlds interpretation of quantum mechanics, which supposes that in every quantum event that could possibly have several outcomes, all of those outcomes are realized, but that they are essentially realized in separate universes. So all the time, with essentially with every interaction between quantum particles, universes are being spawned, are being split off. And that idea suggests that there must also then be almost an infinite number, perhaps an infinite number of universes in which there are versions of ourselves going about our lives, gradually sort of diverging from the splitting point, and that this is happening constantly. And there are people who suggest, crazy though it sounds, the rationale for this is it kind of makes sense, because the truth is that within quantum mechanics there is no prescription for explaining how it comes to be that things that are continually evolving like waves in quantum theory suddenly click into this very concrete this or that when we measure them. There is no prescription for that in quantum theory. We have to sort of clumsily put it in by hand. And the people who support the many worlds interpretation say, well, why do that rather than just assuming that doesn't happen, that actually what you don't suddenly get a sort of disappearance of possible outcomes from an observation. They are realized, but they're just realized in other universes that split at that point of observation or at that point of interaction. So, this makes a lot of sense in terms of the mathematics, because in some ways it looks simpler. But there are various problems with this. One is to do with the technical sort of definition of how you think of how probability appears at all in quantum mechanics, because essentially the many worlds interpretation is saying that everything that could happen does happen. And so you know with 100% probability that all outcomes will happen. That you have this with 100% probability and that with 100% probability, and that doesn't work with probability theory. So there are problems there. My worry about it is that often the people who push this view. It's a view, incidentally, that was proposed in the 1950s by a chap called Everett. And it's often called the Everettian view rather than the many worlds. Many worlds is kind of often seen as a kind of a vulgarization of that idea. They kind of, I think, quite casually accept the idea that, there are just other versions of us that split off. When it seems to me, if you take that idea seriously, it becomes impossible even to speak about it. What it really means is not that there are many versions of you going about their different lives. If you really think about what this implies, it means that there is no you. There is no consistent way that you can talk about a self, an individual person. And often the response to that is, well, why should there be? Who are we to say how physics is meant to pan out? You just have to go with it. You just have to accept that. But it seems to me that makes that interpretation distinct from every single other theory that we have in science, which in the end assumes that there's an us that is here seeing these things and measuring these things. And so it feels to me as though one of the problems with the many worlds is that, but really going with this idea that there are, versions of ourselves splitting off all the time, that this leads in the end to an incoherence. We can't even then use language to talk about our own experience of the world.
Right, and if people would like to know more about that, Beyond Weird is available on online bookstores, etc. I'm going to move straight on to another one. Sorry, I know I'm rattling through today, but we've got the reviews in for the Infinite Monkey Cage you were on, Fay, and here's one from Gilbert. Gilbert would like to know: is time a concept, a measurement, or an actual physical thing? I listened to the Monkey Cage on time, and I think I'm now more confused. So. What again? We're back to that starting point, I suppose, which is
a physical process. It's the coming into being of it's events happening, and those events at their most basic level are the coming into being of the basic fundamental units of reality, which I refer to as space-time atoms. So it's real. It's the physical. It's the most real thing of all. It's a physical process of becoming. Yeah.
Would it be easier if you think at an earlier stage of education, people were introduced that space and time were connected, rather than, I think that's the thing, is people very often, it's in adulthood that you suddenly come across this idea, if you come across it at all, that they're not too, you can't go, there's time there and that just keeps ticking whatever, and there's space there and that does that thing, that space time, that if we learned about, even if just in a very, very simple way, in quite an early part of the educational process, it wouldn't come as such a shock about the interconnected nature of it.
It's interesting that there are always struggles over pedagogy. What's the best way to teach? Given what children and then young people are capable of understanding at different stages of their development. So I think I don't know what the best way to teach is, but I think young children have a much better idea about time than a much more scientifically accurate view of time than the one that they acquire through having Newtonian concepts drummed into them for their whole school education. So what relativity teaches is that really there's no notion of space as a global entity. So that there's no notion, it teaches that there's no notion of simultaneity, global simultaneity. There's no notion of now here being simultaneous with now over in some distant part of the universe. And that's something that you have to learn. You that's not a natural, it's not an intuitive concept because you don't have experience of the universe far away over there. You only have the experience of local things. So that has to be taught and learned. And then after you've been taught and learned all those Newtonian concepts of there being such a thing as three-dimensional space, you have to unlearn them when you come across relativity. So I don't know. But of course, Newtonian physics is fantastically useful. And so
I have heard an idea that this may well happen at some point in the future. It's a really interesting ethical thing where we have now graphics simulations of things that an adult brain can't encompass. But I have heard suggestions that if you perhaps gave those graphic simulations of a four-dimensional universe to a young child, that their brains would kind of adapt to see them in a way that we can't. And I think it's really interesting because obviously children's brains do that all the time. They see things the generation before didn't see and they take them as for granted. And I certainly do that. When I was given a brief history of time, for example, when I was 10 or 11. And so I completely grew up with it, even though I clearly didn't understand all the nuances when I was 10. I just grew up with it. And so there's a really interesting idea about if we get better graphics of what some of these things mean, and you show them to kids, and they sort of, build the brain structures perhaps that let them understand it in a way that we can't because we grew up in this sort of Newtonian world only. But obviously the ethical problems come along with that.
There's a discussion about, this is true of quantum mechanics as well, that there are things within quantum mechanics that are just very, very hard for us to intuit. But some people are hoping that as quantum computers become more widespread, and, already there are quantum computers that schools can use online, can sort of register to use. And the hope is that, if children start doing this, and it's no more difficult than regular computing to actually learn how to program it and run something simple. If they start doing this with real quantum computers, that maybe they will develop the kind of intuition that you just get used to the idea of things like superpositions, which look as though they are things that are more than one thing at the same time. And this seems so counterintuitive to us. But if you grow up knowing that such things can exist, then again maybe you just develop that intuition just develops as it does for anything else that you learn.
Helen, we've got a question from Bob Windmill, who watched your event with the Royal Academy of Engineering this week and wanted your thoughts on this. To what extent is, or perhaps rather should, the environmental impact of mining and transporting the materials needed for green technologies and manufacturing and transporting products be taken into account when assessing the benefits of the future green schemes discussed?
Well, of course it is, and of course it should be, and it already is. Properly done environmental audits absolutely take into account full life cycle analysis. Now, you can get most of it right. There's obviously some slippery concepts in there because you're potentially predicting. Either predicting things that might happen a long way in the future, or you're looking at processes in the past where you can't track everything because there weren't records. But there's absolutely no question that a proper environmental audit includes recycling everything. As we have talked about before, I think the whole world is made of poo. Fundamentally, that's the way Earth works. Things go round and round. You're only ever made from the waste of the previous thing that was there. So it only ever makes sense to do these analyses on a cyclic basis. But obviously in a world that is changing very quickly, it can be a tricky thing to do. But it's already being done. Absolutely. Any good environmental audit, it's absolutely already being done.
Right, well, that's a little bit of a break from quantum, but don't worry, we're back there now. This is from AEJ65. I'd like to know, there's a lot of pseudoscientific woo that misuses the word quantum as an adjective. Deepak Chopra leapt off the edge into that chasm of spiritual nonsense years ago. But I just watched a discussion between Deepak Chopra and Richard Dawkins, and when every now and again you're reminded why Richard Dawkins is so grumpy so much of the time. I had quite forgotten why he puts himself up for these. I have no idea. There will be no happiness found whatsoever. But what AEJ65 would like to know, do any great woo-free writers get close to that precipice while anchoring themselves in the realm of science? So this is quite interesting, because I know you've talked about this before, Phil, as well, which is that uneasy, slightly blurred area. And I suppose to some extent, maybe when we're talking about parallel worlds, perhaps is there a point there where you go, this is just edging towards the precipice of woo, but the equations just allow that to go that far?
Well, I think as far as many worlds are concerned, the equations are silent, to my mind, on whether many worlds exists or not. The Everettians insist that the other worlds are already in the equations, but they're not. I've looked for them. You can look as hard as you like, and you won't find them there. So to my mind, it does encourage, and I mean, you see it all the time, that if anything, I mean, Devs, for example, the recent TV program, if any TV programs or films are made about quantum mechanics, you can be fairly sure that many worlds will surface in that form of, we might have other lives that we live. So, even though that interpretation itself has, I think, a firm foundation, whether you agree with it or not, it very easily lends itself. And in fact, that's why it's so popular, because it lends itself to that side of things. But I think that, the truth is that within quantum mechanics, there are phenomena that happen that really do seem, they seem to invite this because they are so strange. And entanglement is probably the one that, does that a lot as well. So entanglement is something that can happen, and that in fact inevitably happens whenever two quantum particles interact with one another and then go off somewhere. They then form an entangled state, so that in some sense doing something to one particle seems to have an instant effect on the other particle, no matter how far away it is in space and time. And so this, it really sounds like there's some kind of weird instantaneous telepathy between these particles. And within quantum mechanics, the way that's often sort of talked about is not that there is some weird transmission of that effect from one particle to the other. In fact, it can't be that, because that would have to go faster than light to explain what we see. And we know that things can't do that. It's that once they have interacted, you have to, as far as quantum mechanics is concerned, in some sense, they are then a single entity. Even though they might then separate in space, they are still a single quantum entity. And so, you can't any longer think, well, I'm going to look at this particle and expect not to have some effect on the other part of this entity. But it seems to subvert all our everyday notions of how space works. In particular, it seems to undermine the whole notion that there is, space separating them that has to be traversed if one has to affect the other. So this is such a peculiar effect, even though it's entirely well documented and proved experimentally, that it's very understandable how these ideas become used to explain things like telepathy, because it really, there's no getting away from it. It really does look like that, even though scientifically there is absolutely no reason to think that that's really what's going on.
Because that is the telepathy. That seems to me the danger of some of the ideas which get into the public sphere, as you said, which is that because someone like me hasn't been involved for 2 decades doing the working out, I've gone straight from a world in which things cannot, at that distance, if I suddenly move one object here, that immediately my brain just goes, and therefore magic, and it becomes this kind of wizardy, strange magic world, because I've not had to do, I've done none of the work in between. And that I can see, I guess, as you're saying, that's why it becomes so bamboozling, and how we then do see some really, sometimes quite, as we mentioned at the beginning of the show, some of these things are sometimes used in quite a dangerous way as well. Pseudoscience will sometimes pick up terminology, take that 1 or 2 sentences and say, and therefore my potion works.
My view is that we're still in the middle of the development of quantum theory. It was a revolution, but it's an unfinished revolution. We haven't yet come to an understanding of what is really going on in a quantum system. What is the picture that we should have of a quantum reality? That's my view. I don't think it's not settled. And I think there's an avenue of development which has always been there. It's been there since the very beginning, which hasn't been fully explored, which gives us an alternative to this many worlds or not many worlds dichotomy, which is you can get into a bit of a rut with that. And that alternative perspective is called and it's something which is closely associated with Richard Feynman. So it's often called the Feynman path integral. And it's an alternative framework for the theory in which you never have to talk about what gets people hung up, which is this quantum state, which is in this superposition of for a cat, for example, being alive and being dead. So if you take a path integral perspective on quantum theory, there are no states. There's no notion of there being a state, of a quantum state of the system at a moment of time that evolves in time. And that's actually a good thing to not have, because to have a state that depends on time and evolves in time, that requires you to have this notion of a global now, for there to be a time t that this state can depend on and change with. So because in relativity there is no such thing. So in the path integral, the concepts that Feynman based his path integral formulation on are much more relativistic. They are events that take place in space and time, and histories, so whole histories of the system. And from that perspective, you never need to worry about there being a state which is in a superposition of dead and alive. You only ever talk about events, and those events either happen or they don't happen. And I'm absolutely with Philip on this. I don't think that many worlds are a fruitful or useful or even comprehensible way to think about the universe. And I don't think quantum mechanics inevitably leads there. And I think in particular that the path integral gives us an alternative way. It's just you can cut the Gordian knot. You can sidestep that question and think in terms entirely of events. And they are in our universe, they either happen definitely or they don't happen definitely. So that's But I'm surprised that there's all this kerfuffle and confusion, and because I think that's the state of the science is like that. I don't think it's not settled.
Yeah. Faye, I'm not supposed to be asking questions. It's supposed to be the audience about this question of how much quantum mechanics is held back by the human's desperate need to understand a mechanism. It's this attached to that which pulls on that. And you were saying that the history of quantum theory is it's still developing, but we've now had sort of 80 years of getting used to this idea. Do you think that that the scientists who study this, like you now, are still held back by this intuition that there has to be a thing that pushes on something else, these sort of real world mechanism things? Or do you think that once you've gone through all the degrees and you've spent years researching it, you're finally free of having to be held back by those things?
I think it's a mixture of those things. In fact, I think we scientists should really get back to a little bit of that, because what's an orthodox view of quantum mechanics, in which there is this object, the quantum state, which seems to be central to the orthodox view. What that seems to demand of people is that all you ever ask about are predictions about the results of your experiments. So you don't, in fact, ask about the mechanism. So you have a box, and your quantum system is in the box, and you don't ask the theory for a picture of what's going on inside the box. You just say, if I do this operation on the box, then I want my theory to predict the results of my operation. What will I observe? I don't ask about what's going on inside the box when I'm not experimenting on it or not watching it. So I'm not asking for the mechanisms. I'm not asking for a picture of what's going on, what's causing what. I'm just asking for it to tell me what I will see if I do my experiments. And I think that's regressive. I mean, that is a sort of giving up on the purpose of science, which is to understand. I want to understand what's going on in the box, not just what will happen outside the box if I twiddle this knob. What readout will it give me on the screen if I set it up like this? I don't want that's not particularly interesting. I want to know what's going on inside the box. And I think this orthodox perspective on quantum mechanics has driven people into a corner where they're now saying, well, we don't need to know what's going on inside the box. So long as we get the right results for our predictions for our experiments, we don't need to have a picture. So I think getting back a little bit to asking for an understanding of a quantum system, an actual picture of quantum reality, I think would actually advance us more.
Right, I think we're going to accept that we're not going to get through all the questions today. But I see how many we can get in the last 10 minutes. I knew this was going to be an interesting one. This is from Matthew Cobb. I think it's that Matthew Cobb at Manchester University, and he would like to know, what is spin? Is it a metaphor, or do electrons really rotate? Phil. That's when people hear, again, someone like me, when you hear spin, of course, the picture theory you're getting in your head is probably very different to the actual reality. If there is reality.
It is and it isn't. So here is, when we talk about quantum spin, here is why we talk about it as spin, because when everyday objects like a ball spin, they have something called angular momentum. Okay, and quantum spin is a property that gives quantum particles angular momentum. So it looks as though it's the same kind of thing. However, it doesn't behave in quite the same ways as classical spin does. Looked at one way, it almost looks as though a quantum object, in order to spin, to come back to where it originally was, it has to kind of go through 2 revolutions rather than 1, which doesn't quite, you can't really develop an intuitive picture of what's going on there. But, when we do things like that, it's because we are trying to force a kind of classical picture onto this quantum thing. So, that's why it has this label. That's why it's called spin, because it looked like everyday classical spin, but it's not the same as that. And it's one of those quantum properties, and there are others that fundamental particles have, that we just have to say, there is no classical analog to this. There's one that's quite close to it in the case of spin, for the reasons I've said. But there are other properties that quantum particles, certainly subatomic particles that make up the nucleus, for example, have, that we just have to kind of use as labels, because there's no, things like color. It's nothing to do with color in any normal sense. This is just a label that refers to a quantum property that just has no classical analog. So I think that's the best I can do for spin, to say there are reasons why we think of it a bit like a spinning thing, but it wouldn't be correct, or at least we have no reason to think of it as, for example, a little electron spinning around. As far as we know, an electron is just a point, so I don't even know what it would mean for it to be spinning. So yeah, it's one of those situations where we just have to live with the fact that the quantum world has these properties of particles that don't have classical pictures to tell us what's going on.
Right. Thank heavens we're going back to something simple next week, like human consciousness. We'll get through so much then. This is from Kay. This was actually a question from last week. I'll ask you this, Faye. Kay would like to know, how does speed affect gravity, or does it not? What I mean is, as an example, why can a motorbike lean over past 50 degrees and not fall over when it's going very fast, but fall over again when it's at the same angle going slowly? And the same with the spinning top. So that's gravity. Where does that fit into that picture case?
Oh, so those are, you can work in a Newtonian framework to answer those questions. Because actually, if you take a relativistic perspective, then the notion of speed becomes relative. So you can only talk, speed itself is not meaningful, but you can have to talk about relative speed. Okay, so for the motorcycle, it doesn't affect gravity. What it's affecting is the friction, the frictional force between the tires and the ground. So in order to not fall over, there has to be enough. Let's see.
I'm so glad this is you, Faye.
I find it sometimes helpful example of a velodrome, where you've got those banked sides. It's a bit more obvious where the forces are coming from. I don't want to interrupt you, Faye.
No, that's right. So that's right. So when you're going around, good. When you're turning a corner or going around a curve in a velodrome, there needs to be a force on you that is pushing you towards the center. That's people call that the centripetal force. So you're actually, when you're going around in a circle, you're actually accelerating. Even if you're going at a constant speed, you're accelerating. And the direction of your acceleration is towards the center of the circle. So that force is higher the faster you're going. So you can go around in that circle if you're going fast enough, because that acceleration will be fast enough to push you towards the center of the circle. But if you're going too slowly, then there isn't enough force on you to allow you to go around the circle.
Can I just add that bicycle mechanics was still being debated, some of these basic questions, certainly when I was an editor at Nature, and as far as I know, it's still being debated now by physicists. So it's
why is riding a bicycle a stable?
Exactly. So so this is an much harder problem than you might think.
Nevertheless, people can ride bicycles.
Exactly.
Well, highly recommend if talking with David Eagleman the other day in his latest book, he talks about Destin Sandlin's fantastic bicycle, or at least the bike that he promoted, which is the bike that if you turn the handlebars right, the wheel goes left. And I've had a go on it, and it's really fascinating. And if you look, I forget what the actual YouTube channel's called, but look up Destin Sandlin and look up a reverse bicycle, and you will see something very fascinating. It's on a somewhat different issue, but nevertheless, while we're going through the bicycle portion of the show. Also, Kay, please take the corners safely, though. Do not, just because you're in an experimental frame of mind in terms of the nature of physics, if you're in a built-up area, please don't go at 50 miles an hour. There we go. We've covered our legal asses there. This is from Joe N. Joe N would like to know, I always see the double slit experiment used as a way to explain quantum physics. My small issue is that I don't understand the double slit experiment. Now, this, again, is something where I would say when you first hear this, and when you second hear it, and when you third hear it, and when you keep hearing it, we feel there was a world we knew, and now there is a world that is changed. Faye, would you like to take that first of all?
So that saying you don't understand it means that you have understood it. So if you hear about the double slit experiment and you say, yeah, what's the problem? Then you clearly haven't understood the description of what the results are. So the fact that you don't understand it means that you haven't. I mean, you've understood the setup, and you've understood the description of the results, which are quite extraordinary. So what happens is that when you have one slit open, then the particle has only one way to go, through the slit, which is in this metal screen, for example, and it lands and makes some scintillation on a backstop. So
should we just so people have got a clear picture? So if you imagine we'd use the normal thing, which is you draw a diagram, Helen, as well, which is you imagine a kind of a gun that fires out a particle in the middle of this box. If we imagine it as a shoe box, there is a single slit on this occasion, and at the end is a screen which will then detect what has happened. So just to give that just some sense of
good. Where are we? Can you see where we go? Yeah, if it's that way around.
That way around, yeah.
So the particle, if there's one slit over slit, then the particle can make it through and get to the backstop, right? And it makes a little flash. So if it's an electron and it's a sort of cathode ray tube, then it makes a little scintillation, a little flash. And over time, with this one slit open, you can make a nice pattern of the build-up of all these scintillations on the screen, and it's all uniform. So there'll be a sort of uniform spread of where the particles hit the screen. Okay, and then you can do that for the second. Cover the first one, let them go through the second slit, and again there'll be a nice uniform spread of these scintillations on the backstop. Yeah, so cover right. Again, a nice uniform pattern of scintillations on that backstop. Okay. Then what you do is you let them, open both slits. Now the pattern becomes really weird. It becomes striped. There'll be stripes. So there'll be patterns of places where the particle can land. And in between, there will be gaps where it can't land. Now, all those places, all those so-called dark bands, are places where the particle could get to if one slit was open. But with two slits open, it can now no longer go there. It could go there with one slit open, but with two, it can't go there. So that's fall off your chair kind of weirdness. So what the particle does depends on what possibilities it has open to it. And there's a nice joke about that. Okay, so whether you find this funny or not, it's probably tell you something about yourself. Okay, so this is the parable of the quantum pie eater. The quantum pie eater goes into the pie shop and says to the pie shop owner, what pies do you have today? And the pie shop owner says, oh, I've got apple and blueberry. And the pie eater says, oh, I'll take the apple pie, please. And then the pie shop owner says, oh, wait, actually, I forgot, there's also cherry pie. And then the pie eater says, oh, in that case, I'll take blueberry.
Now, the way to set that, you see, I reckon.
I don't know. I find that funny, but.
But when you're doing a gig, you see, this is what we can do various psychological tests on this with your setup, because I think if you'd set that up by saying, now, whether you get this joke or not and how funny you find it depends on your level of understanding. Now, I reckon if you say that in a lecture hall, a number of people who haven't got it at all will still go, I don't, but I better. So the psychology, we'll deal with that next week on the brain. We've got one more question that we're going to deal with. I'll just quickly thank you again to everyone who's watched and everyone who's supporting us via Patreon, or if you are able to put any money in the tip jar, that's fantastic. And a reminder that the Andrean conversation with Brian Cox and I is now up on the Cosmic Shambles YouTube channel, and if you can subscribe to that, that is fantastic. And Helen is also she's appearing in the this week's Maths with Matt Parker as well, and I also mentioned, of course, Phil's latest book. There are 4 more on the way, by the way. A latest book, How to Grow a Human, which is why the world will eventually be populated by this kind of incredible number of Philip Balls, which will then lead to some kind of strange panspermia across the entire galaxy, and it will all be Philip Ball creatures. And you can't get Fay's book. She hasn't written it yet, have you? Are you going to write a book, Fay? I hope you do. Because I love your lectures. Your lectures, I think. Yeah. So Facebook will be available, if not in this universe, in another universe. She has written one. See, I haven't understood anything Phil said at all. So the final question, I'm going to really balls this up. This is from Steve Thompson, who's a wonderful musician, amongst other things. And he goes, here's a long form one. And it is said, citation needed, that this paragraph is the most beautiful ever written about physics. The question is why, and for us mortals, what does it say in English? If one wants to summarize our knowledge in the briefest possible terms. So here, right, I'm not even going to be able to read all this because it involves terminology, and I don't do terminology, right? So if one wants to summarize our knowledge of physics in the briefest possible terms, there are 3 really fundamental observations. 1, space-time is a pseudo-Riemann manifold M endowed with a metric tensor and governed by geometrical laws. 2, over M is a vector bundle X with a non-abelian gauge group G. 3, fermions are sections. Right, anyway, so you get some idea. Right, first of all, what is that? Who recognised it?
I recognise it because Steve's answer him then.
Great. Okay, that's good. Steve, you merely did that to torture me. That we didn't, as I said, we didn't cover everything. There were lots of wonderful questions, including ones which were just about the definition of indeed what quantum physics is. And as I mentioned before as well, I really do highly. We did a wonderful event with Philip and Alan Moore, which I think is it fair to say, Philip, that you were surprised that not merely had Alan in the space of a couple of days read the entirety of your book, understood your book, and then beyond that, I think also understood the ramifications of the book. It was quite, because I just looked at your face at one point with you kind of going, "Whoa!" In 48 hours, this man's done.
I was touched, of course, that he read it. I was flabbergasted that he understood it, and he was starting to explain it better than I could. So you need Alan to talk about this stuff.
It is such an interesting. So Phil, I've mentioned you've got a few more. When's the next book coming out? The latest one has only come out quite recently, hasn't it? How to Grow a Human.
It came out, yes, last year. The next one I have out, it's not a science book. It's about modern myths, and it's looking at the stories that we have told in modern times that have, I think, acquired genuine mythical status. And they're kind of probably the obvious ones once you start to think about it. Frankenstein, Jekyll and Hyde, Robinson Crusoe, Sherlock Holmes, and it's looking at what we mean by a modern myth and why those stories have become mythical. I need to talk to Alan about that as well, clearly. In fact, Alan is in the book, naturally. The League of Extraordinary Gentlemen.
Which is so much fun. Please, anyone watching this, if you've avoided seeing the film so far, continue with that habit. It is one of the most remarkable maulings of something which Kevin O'Neill and Alan Moore created, something so funny and beautiful and adventurous. And the film is none of those things. Helen, what are you up to?
To be honest, I've got a boring answer because I'm a university academic. So, of course, I'm shifting all our teaching online. That's all I've done for 4 months. I'm supposed to be writing a book about the ocean, but it has been neglected during all of this. Also, because I can't go to the ocean, which is very frustrating. So I'm sort of I have no particularly exciting projects to report. I'm sorry.
And Fay, I presume you also, in terms of an Imperial, are you having to record all your lectures for next year? Is that currently the thinking of how that's going to happen?
To move to a mixed hybrid system, it hasn't been set completely whether all of our lectures are going to be online, but it looks likely that most of them are. But there'll still be labs, so there'll still be in-person laboratory experiments and teaching.
I really recommend, actually, if you get a chance, watch some of Anil's stuff that he's done, TED Talks and TEDx Talks, because if you're looking for, there's so many interesting ideas in those, and of course Ginny, of course, explored a lot of those ideas in her books as well. But if you Anil's TED Talk, the main TED Talk in particular, I think is will set you off in many different areas. So if you've got any questions about the human mind, consciousness, our experience of the world, our subjective experience, the nature of death, etc., then send them to us and we'll ask them at next week's Sunday Q&A. And thank you very much to Trent, as usual, who produces this show every week. Keep an eye out on the Cosmic Shambles channel. As I said, we've got new things every single week, sometimes 3, 4, 5 or 6 different things every week. Thank you again to everyone for joining us, and see you next Sunday.